Hello there, my name is Neil Jerson Natalis of VSE1, and today we are going to solve challenge problems using one of the techniques of integration, the integration by parts. So I have two problems here. Number one, we have cosecant raised to 3 theta d theta. So first, we will integral. We will separate one cosecant here like that, and then using trigonometric identities, cosecant squared will become 1 plus cotangent to theta. Wait. It will become cosecant theta 1 plus cotangent squared theta d theta. So next we will multiply cosecant to both of these terms here, so it will become cosecant theta plus cosecant theta tangent squared theta d theta. And then next we will find the integral of cosecant theta, which is negative ln of cosecant theta plus cotangent theta plus tangent theta. And then for this term here, we're going to use integration by parts for that. Theta cotangent squared theta d theta. Okay, next first we're gonna separate cotangent squared, so it will become cotangent theta cosecant theta cotangent theta d theta, like that. So now we're gonna use integration by parts. We have u, let's make it smaller, u, du, v, and dv. We'll use cotangent theta for our u, and for our dv it will be what remains, cosecant theta cotangent theta d theta. So next I will find the derivative of cotangent theta, that is negative cosecant squared theta d theta, and then find the integral of cosecant theta cotangent theta d theta. It is negative cosecant theta. So next, using the formula uv minus integral of v du, we will use it on this term here, this function. So copy this first, negative ln cosecant theta plus cotangent theta plus, and then uv, which is cotangent theta times cosecant theta minus that's negative cosecant theta minus integral of negative cosecant theta times negative cosecant squared theta d theta. Next, multiply cosecant and cosecant squared, and then copy the others. And then also multiply both of these terms here, so it will become negative cosecant theta cotangent theta. Minus cosecant cube theta d theta. So as you can see, this integral here is the same as the original integral, cosecant cube theta d theta. So first we must copy all of it to proceed. So copy, so as you can see, we have this same terms here and this. So what we're gonna do is transpose it over here, so we can have 2, since cosecant, if you plus both of this, it will be equals to 2 times function here. So it's 2 times integral of cosecant cube theta d theta equals to negative, and just copy, so what we're gonna do with the 2 here is we're gonna divide both sides by 2 to cancel out 2 on top of that. So we will have 1/2 times a negative ln cosecant sorry, it's this is supposed to be cosecant. This is supposed to be cosecant. There. That too. Cosecant theta plus cotangent theta minus cosecant theta tangent theta. So as you can see, this is the final answer: 1/2 times negative ln absolute value cosecant theta plus cotangent theta minus cosecant theta cotangent theta. Next problem. Next problem, this is easier compared to number 1. So first I will find the u, the du, the v, and the dv. We can get u and dv from this function here. So u will be arctan z. Its derivative is dz all over 1 plus x squared, z squared. And then for v we'll have z, for dv we have z dz, and if we find the integral of the z dz, it will become one half z squared. So if we follow the formula of uv minus integral of v du, we will get z squared over 2 arctan z minus the integral of z squared all over 2 times 1 plus x z squared dz. So next, just bring out the constant. So what we're gonna do next is this. Like that. And then if we minus both of these terms, they will become 0. So what's left is 1 over 1 plus c squared plus 1 dz. 1 over 1 plus c squared plus 1 dz. Now let's find the integral of both of these terms. This will become arctan z, same as this, as you can see here, and then this will become just z. Arctan z plus z plus c. This is the final answer. Yeah. Next, we'll have challenge problem for an application of integration, which is areas between two curves, and these two curves are the y equals to x squared and y equals to square root of x. As you can see here, this is the graph of these two curves, and if we plot it first, x and then y equals to x squared, 0 raised to 2 is just 0, 1 raised to 2 is 1, 2 raised to 2 is 4. Next, y equals to square root of x. 0 will become 0, 1 is still 1, and then 2 is 1.414. Oh. As you can see, we have 1 as the same points here, so this is equals to 1, 1.11. Now if we look at it, the vertical strip here is dx below, and then y1 minus y2 on the side. So if we solve for it, we have the derivative of the area, this is the area right here, is equals to multiply y1 minus y2 dx. As you can see here, y1 is the one on top, the curve on top, so it's square root of x, and the y sub 2 is x squared. So but first, if we get the integral of these two here, we'll have a, or area, is equals to the integral of y1 minus y sub 2 dx. So substitute y sub 1 and y sub 2. We will have, let's put it here, we will have square root of x minus x squared dx. Now let's find, forgot the b and the a to for the different integral. So the b is the one where they intersect right here, and the a is where they started to where they first intersect, which is the origin. So a is equals to the integral of square root of x minus x squared dx is 0 to 1. So find the integral of square root of x, that is 2/3 x raised to 3 over 2 minus x squared will become 1/3 x cubed, 0 to 1. Now if solve for it, we'll have 1, 2, that's for the 1, and for the lower function 0. If we look at it, I'm sure that the answer will be 0 over here. So 1 raised to 3 over 2 is simply 1, and 1 raised to 3 is 1. So if we multiply it to the fraction 2/3 and 1/3, it will remain as is, like that. So if we subtract 2/3 to 1/3, the answer will become 1/3 square units. And that is the final answer. That's all for today. Thank you for watching. I hope you enjoy.